Hello guys, and welcome back to BC Calculus. This is where we're talking about Taylor-Maclaurin series, and right now we are in the middle of lesson number 23. In the first video, we talked about how to derive the Maclaurin series for sine and cosine, and one of the things that we just have right here as a summary is that sine is an odd function, and I mentioned that cosine is an even function, and I should have also said that sine is an odd function. And so all of your exponents for sine, and this again from Maclaurin series, are all going to be an odd number, right? So 1, 3, 5, 7. And then for cosine being an even function, all of our exponents are going to be an even number. So 0, 2, 4, 6. And so another cool thing about this is that if you were actually taking the derivative of sine, if you actually were to take the derivative of this function right here, you're going to get the cosine function back. So you could just essentially find the sine one, but it's easy. Students don't struggle with this. But if I do this, it'd be 1, or its derivative of x is 1, and if I move the 3 down, so 3 to the 1 less power, so 3 over 3 factorial is actually just going to be 2, right? Which is 2 factorial, because 3 factorial is 6. So 3 over 6 is 1/2, and this is 1/2. So that's just a really cool thing to think about if you guys need to as well. So in this video, we're going to first of all talk about what most likely they're going to have us do. So we're going to do some application problems with this now, and then in the third video we'll talk about the 1 over 1 minus x. So it says find the Maclaurin series for f of x equals sine of 2x. So this is very common on the BC exam. There's usually one of them, usually every year, every other year on this, where I have to find y equals sine of 2x. So very quickly, we're going to go ahead and write down what the Maclaurin series is for sine. So just what is sine of x? So the Maclaurin series for sine of x. And so again, I think sine's odd. So I'm going to do x. I'm going to do minus x cubed over 3 factorial plus x to the 5th over 5 factorial. Now, I really just need that little guideline to kind of assist me on this right here. And so sometimes and usually they would say, you know, find the first 5 terms or find the degree of 5. So let's just say for this one, they want us to find the Maclaurin series of this, and they want us to find the first 4 terms. So we want the first 4 terms of this, so we know we're going to stop. Well, we're going to go ahead and write, this is the first term, the second term, and the third term, so we're going to go ahead and write the 4th term out like this. Now this is the 4th term of sine of x. Now guys, this is how simple this actually is now with the sine of 2x. So everywhere you see an x, you're going to replace it with simply 2x. So sine of 2x, and I'm going to go ahead and write it over here just so we have more room. The sine of 2x is going to be equal to 2x minus, now be careful, it's going to be 2x quantity cubed over 3 factorial, and then plus 2x over 5 factorial, and then minus 2x to the 7th over 7 factorial. So we want to make sure that we remember that now all we're doing is we're substituting in. And this works for anything, any function that you have, we're going to replace it. So I always tell students initially when you guys are just learning Maclaurin and Taylor series to just take a second and maybe write the second, I say write about 3 terms. 3 terms gives you an idea about the sign, like if it's positive or negative, and then which exponents we want to use. And then, you know, the answer that you would see on the exam would be it's most likely simplified, okay? It's not guaranteed to be simplified, but you're going to see 2 cubed. 2 cubed is 8, and then 3 factorial is 6. So you're going to see 4/3 x cubed. So this is where it gets a little bit, you know, not challenging, but just a way for you to see this. So this is going to, again, be 8 over 6, which is 4/3. Plus, and then sometimes when they get really large, especially when you get to this one, then they probably won't simplify it as much. But 5 factorial is actually 120, right? It's 5 times 4, which is 20, times 3 is 60, times 2 is 120. So the bottom is going to be 120, and then the top is going to be 2 to the 5th. So 2, 4, 8, 16, 32. And I'm not going to simplify this right now, but you know, you guys would simplify that if they would simplify that for you. And then we're going to go ahead and do minus. And then for this one, let's just, you know, just say what it is. So this was 128 x to the 7th, and let's just leave it at 7 factorial. I mean, usually it's a calculator problem or, you know, whatever, but, you know, the idea here. So that's how you do these problems. And again, you can use a calculator to simplify this and simplify this if you need to. But this is the idea of what's going on. So I encourage you guys, now that you've seen this example for sine, to look at example 4 and see if you guys can find. And we're going to do this one a different way. Let's say instead of looking at terms for this, I want a degree of 4. I want a degree of 4. So again, 1, 2, 3, 4 terms. So I want a degree of 4 here. So if you need to take a second and put a break and pause it and do it, great. And then we're going to come back and do the problem. Okay, so let's go ahead and do this. And again, it says Maclaurin series, so C is going to be equal to 0. So again, I just go ahead and take a second here and do what cosine of x is. I know this is an even function, but please don't forget about our guy with the 1, right? Cosine of 0 is 1, so please don't forget about the 1, because students always just want to start with the x squared. So it's x squared over 2. And since I want a degree of 4, then I can stop on the third term. So this is all that they're asking us to do. Now, you don't really have to write this out, but again, just as we're starting out practicing these things, it's just really nice to have these things in the back of your head. And so we want the cosine of x over 3. So just like in the previous example, anywhere I see an x, I'm going to replace it with x over 3. And so it's going to be 1 minus x over 3 squared all over 2 factorial plus, that's supposed to be an x, that was horrible, plus x over 3 to the 4th over 4 factorial. And again, we don't like fractions instead of fractions, so this would be 1 minus, so x squared, and then it's over 9, and then we have 1 over 9 divided by 2, which is just going to be over 18. And then plus, we're going to have x to the 4th. We're going to have 3 to the 4th, which is 9, 27, 81. 81 in the bottom. I'm going to do a little side note here. Times 4 factorial. 4 factorial is going to be 24. Oh, that's going to be a huge number. So let's just do 81 times 24 is our answer. We're not going to do more. Sometimes you just see 3 to the 4th. And usually, guys, what I see and what I would suggest that you do, honestly, instead of having 81 times 24, what I suggest, and actually let me do this for both of them, just because I don't want to freak you guys out with, because some of these questions are not calculator. So what else could we see here? So you could see them do like 3 squared times 2 factorial, 3 to the 4th times 4 factorial. So that's another way of thinking about doing the question. So that's another way for you guys to see it. And then yes, the simple ones, like 18 here, and this is just too large to count. But there we go for those 2 examples. So now you guys should be pretty comfortable with the Maclaurin series for sine and cosine, and now how to manipulate them. And that's all you do. And hopefully you guys now have an understanding of terms versus degrees. So we're going to do one more example of this, and then we're going to move on to the next video. Okay, so sometimes it actually asks us to not give a function, but they give us all the information. It says write a third degree Maclaurin polynomial for this function, and they give us what the derivatives are. And so since we know it's a Maclaurin polynomial, we know that c is going to be equal to 0. And another way that we know this is that you can see that all of these values here are 0. Right? We're not plugging in a value for c. And we are going to do Taylor series in a little bit as well. But this is actually pretty basic, and this question would be given to you just to make sure that you guys would be comfortable with the actual equation for Maclaurin polynomial. So if you guys remember, the very first thing is what f of 0. So we want to write down the 5. Write down the 5. And now this is our 0th term, if you want to call it like that's really our first term, but get the idea. So once we're looking at a first derivative, so we're going to write out what f prime of 0 is, which is a -3, and then it's going to be x to the first all over 1 factorial. So x to the first over 1 factorial. And this is all that we really have to do. And now we're going to do plus our second derivative is 1, and since it's the second derivative, this is our everything all about 2. So to the second, 2 factorial. Then our third derivative is going to be plus 9, right? This is f cubed, or this is x cubed. The third derivative of 0 is 9, and again, it's x cubed over 3 factorial. And that's all that we do. And, we do want to simplify this as much as we can. So this is going to be 5 minus 3x, and this one's pretty easy to do here, plus x squared over 2 factorial, which is just simply 2, and then plus 9 over 6, this is 3/2 x cubed. And so this is a third degree. So again, notice that it's asking for third degree. So there's 4 terms here, but the highest number of our power is going to be 3. So this is the answer that we want. Okay? So again, just with many examples, I hope this makes sense to you guys. And I will see you guys in the next video.